there's an exception to every rule. And that could not be more true with our discussion of 802.1q trunk links. What is the exception? Well, I'm going to give you a rule. All VLANs are tagged as they go across a trunk. That's the point. A trunk is there to tag our frames. But if I were to say all, and not conditionalize that all VLANs are tagged, then I would be lying to you. And the lie would be, there's a little secret. There's a dirty truth about 802.1q trunking, and the dirty truth is the native VLAN doesn't get a tag. Native. What is this? This literally is the untagged VLAN. So they're showing us a beautiful picture here. VLAN 1 is presently and is the default native VLAN. You can manipulate it. But VLAN 1, let's assume that's the native VLAN for all of our trunks, which is a good assumption, unless it's modified. This VLAN doesn't get a tag as it traverses the trunk link. Now, there's stories on why this is good. It isn't good. It's not beneficial to us. But it was a decision, and we are affected and stuck with this decision. Notice that VLAN 1 doesn't get a tag, but VLAN 50 does. And VLAN 2 through 4094 would get a tag. It's just VLAN 1 that doesn't get a tag. Now, here's the problem. The problem is when one side has a modified native VLAN. Because what happens is, let's say we did this command just on one of the switches. Switch port trunk native VLAN. Then what we get is VLAN hopping. That's not good. Hopping is like you're hopping on a train. If you're hopping on a train, that's not good. You probably stole your tickets. If you're VLAN hopping, you just jumped off of your tracks onto a different track, onto a different VLAN. So let's do that. Let's say that this was done on the right-hand switch, switch 2. And I'll put in an ID here for switch 2, switch 2. Okay. So now what's going to happen is if a frame goes across, leaves, and then is received on this port, the receiving port says, oh, you're not tagged, so I'm going to assume you're part of my native VLAN. But my native VLAN is different than switch 1's native VLAN. So this would, in fact, jump from being a frame for VLAN 1 jump from being a frame for VLAN 1 to VLAN 99. As it crosses a link, somehow it just spontaneously changes the subnet that it's part of, the broadcast domain that it's part of. This should look bad to you. And I've helped students out that have had issues that were caused by this. So if you change the native VLAN, you must do it on the opposing end of that trunk. Now, it's a link-by-link choice. Each trunk link gets its own native VLAN. And that's okay, but you want to be consistent. A lot of people choose 99. This is no coincidence. This is a convention. Some people do 999. And there are reasons to modify this. Specifically, VLAN 1 is more exposed. VLAN 1 is more exposed. The native VLAN of a link is more exposed for hackers. There's something called Q&Q tagging, and if you do that nefariously, you can attack the VLANs that are involved in the native VLAN. Now, it's kind of a convoluted attack. It's not massively impactful typically, but securing your network from a layer 2's perspective does mean changing your native VLANs, and I would encourage you to change it to something like VLAN 99 or something that matches your internal documentation and standards. So let's make sure we understand all of these bullet points because they are meaningful. The native VLAN has untagged frames. Both sides have to match. I explained that. You're going to get merged traffic. I just showed you that merger. VLAN 1 and 99. This is a bad thing. The default native VLAN is VLAN 1. Let's confirm that right now. Show interface trunk. No trunks yet. Let's rectify that. Switch port, mode, trunk. Do show interface trunk. And we can see it right here. That native VLAN is going to default to 1. You can modify it with the command we gave you. Switch port, trunk, native VLAN 99. Do that on both sides, and you'll be right as rain. Everything will be good in your config, at least with regards to the native VLAN.